Hi everybody, this is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to learn the definitions and terminology of Fourier series, which is the last topic of linear algebra and calculus. We all know that knowing about whenever you want to do the problem on particular topic, it is better to we should have the minimum knowledge of the definitions and terminology that are frequently used in that unit. Otherwise, the concept cannot be understood clearly. So the very first definition is define Fourier series. Define Fourier series. Fourier series is an expansion of a periodic function in terms of infinite series of geometric functions, which represents an expansion or approximation of a periodic function used as Fourier analysis. This Fourier series is applied to the problem, is applied to the functions which are periodic in nature. That means which gives same values after regular intervals of time. So for that type of functions only the Fourier series can be applicable, and it gives the expansion model of any function in the particular integral, not in general. For the interval that we have chosen, in that interval, how to give the expansion model of a given function in terms of sine and cos, so that it gives the Fourier series. Now, define Fourier series. If f of x is a function, f of x is a function. Now let us know how to define the Fourier series in general, and how to define the Fourier series of odd functions, how to define the Fourier series of even functions. So all these three different categories are there which we have to learn. So the first, going to the define Fourier sine series. If f of x is an odd function, then half range series, sine series of f is defined to be f of x is equal to summation n rises from 1 to infinity bn sine n pi x by l. And where Bn is called as a Fourier coefficient, and which takes the form of 2 by L integral of 0 to L f of x sine n pi x by L dx. Actually, in the Fourier series, we have, if f of x is any function, that the Fourier series in general is given by a0 by 2 plus summation an cos nx, summation an cos nx plus bn sin nx. This is a general Fourier series expansion where n rises from 1 to infinity. And here a0, an and bn are called as a Fourier coefficients, Fourier coefficients, right? Okay, so for few intervals, the function is neither even nor odd, or sometimes he will ask you to only the Fourier series. So in that case, all the three Fourier coefficients we need to find it out, where a0 takes different value, an takes different value, and bn takes different value. So here in half range series, we have only the last Fourier coefficients, that is bn, and a0 and a0 and an both will become 0 for sine half range sine series. So bn takes the value of 2 by L integral of 0 to L f of x sine n pi x by L dx. Okay. Next, cosine series. If f of x is an even function, then Fourier cosine series is given by f of x is equal to a0 by 2 summation n rises from 1 to infinity an cos n pi x by L, and an is equal to 2 by L integral 0 to L f of x cos n pi x by L. So here we have a0 and an value. Here I'll write it once again. If f of x is an even function, then it is given by a0 by 2 plus summation n rises from 1 to infinity an cos n pi x by L, and where an is equal to 2 by L integral of 0 to L f of x cos n pi x by L dx, and a0 is equal to 2 by L integral 0 to L f of x dx. So these are the first Fourier coefficients, a0 and a. And for half range, this cosine series, half range cosine series is the last Fourier coefficient Bn will become 0. The last Fourier coefficient Bn will become 0. Next, what define the periodic function? This is a must and should. Of course, we don't calculate for every question whether they are periodic or not, because obviously when the functions are given to expand it in the Fourier series, they will be periodic in nature. So what is a periodic means? The periodic functions means the functions which gives same value again and again after regular interval of time. Because we all know that sine 0 is 0, again sine pi is 0, so its sine value is giving 0 value at 0, and also again at 180 degrees, and again if I rotate to again 180 degrees, again it will give 0. So when you rotate 360 degrees like that, the few trigonometrical functions gives the same values again and again. So the length with which they are giving the same value is called as a period. So here in mathematics, a periodic functions plays very important role, and because for only these type of functions we are going to give the Fourier series. In mathematics, a periodic function is a function that repeats their value in regular intervals or periods. The most important examples are the trigonometrical functions which repeat over the intervals 2 pi radians. That means after every 2 pi the value of the trigonometrical functions will be repeating again and again. Next, define a periodic signals. A signal is periodic in signal if it completes a pattern within a measurable time frame and called a period, and repeats that pattern over identical subsequent periods. With this, because a periodic function, because the graph will be in the same shape after regular intervals of time, and the study of these graphs becomes very easy if the functions are periodic in nature. Okay. Next, define Dirichlet conditions. I've said that for all functions, the Fourier series cannot be applicable. It cannot be applicable only for functions which accepts the Dirichlet conditions. For those type of functions only the Fourier series can be applicable. So what are the Dirichlet conditions? The Dirichlet conditions are the sufficient conditions for a real valued periodic function f to be equal to the sum of its Fourier series at each point where f is continuous. Moreover, the behavior of the Fourier series at point is discontinuity is determined as well if it is a midpoint of the values of the discontinuity. So these are the conditions, these are the definitions of the Dirichlet conditions. Then when a function is said to be absolutely integrable, an absolutely integrable function is a function whose absolute value is integrable, meaning that the integral of this absolute value over the whole domain is finite. If the integral of a absolute value over the whole domain is finite, then you can say that it is absolutely integrable. Next, what is define a continuous function? A continuous function in this definition plays very important role in mathematics. A continuous function is a function in which sufficiently small changes in an input results in arbitrary small changes in the output. Otherwise, the function is said to be discontinuous function. Okay. So the next, that means if you want to learn the definition of the continuity of the function mathematically, the left hand limit should be equal to right hand limit, or the limit of the function at a point should be equal to the functional value at that point. So then also the functions are said to be continuous. Now, what are the discontinuous functions? If the functions are not continuous, that means at any point if there is a LHS is not equal to RHL, that is left hand limit is not equal to right hand limit, then you can say that the functions are discontinuous with each other. Define the Fourier series. Fourier series is an expansion of the periodic function in terms of an infinite series of trigonometrical functions which represents an expansion or approximation of periodic functions and used in the Fourier analysis. Next, to what values does the sum of the Fourier series of f of x converge at the point of continuity x is equal to a. The sum of the Fourier series of f of x converges to the value f of a at the continuous point x is equal to a, because one of the condition that the function to apply the Fourier series is that the function should be continuous. That is why we can give that it should be continuous at a point x is equal to a. To what values that the sum of the Fourier series f of x converge at a point of discontinuity x is equal to a. In the previous one we have continuity, and now we are discussing about the discontinuity. At the discontinuous point x is equal to a, the sum of the Fourier series of f of x converges. That is, f of x naught is equal to limit of h tends to 0, f of x naught plus h plus limit of h tends to 0, f of x minus h divided by 2. Write the formula for Fourier constants for f of x in the interval minus pi to pi. I've already said that these Fourier constants are also called as a Fourier coefficients. So here the Fourier constants, the a naught, a n, b n value are a n in the interval, because based on the interval there will be a little change in the angle. So in the interval minus pi to pi, it is given by a naught is equal to 1 by pi integral minus pi to pi f of x dx. Similarly, a n can be given as 1 by pi integral minus pi to pi f of x cos nx dx. Similarly, and b n value can be given as 1 by pi integral minus pi to pi f of x sin nx dx. So these are the Fourier constants for in the interval minus pi to pi. Now, next one. Find Bn in the expansion of x square as a Fourier series in minus pi to pi. So, since f of x is equal to x square is an even function, the value of Bn will be equal to 0, because if for an even function, the third Fourier coefficient Bn reduces to 0. So, therefore, without finding the Fourier constant coefficient Bn, I could able to say that the value will be equal to 0, right? Next, find the constant term a naught in the Fourier series corresponding to f of x is equal to x minus x cube in the interval minus pi to pi. So, a naught will be equal to 0 here. A naught will be equal to 0 here, because you have x minus x cube dx, right, from minus pi to plus pi. So that can be written as x square by 2 minus x to the power of 4 by 2 at the interval minus pi to pi. So if you substitute this interval, this becomes pi square minus pi square by 2, and the lower interval, that is pi to the power of 4 minus pi to the power of 4 by 4. So obviously it will be equal to 0. This is a one claim. Another claim that f of x is nothing but x minus x cube. So what is f of minus x? F of minus x is nothing but minus of x minus x cube. So since f of x is equal to f of minus x, f of minus x is equal to minus f of x. F of minus x is equal to minus f of x. You can say that the Fourier coefficient Bn reduces to 0. Okay. So the next one, because this is an odd function. For odd functions, Bn will be equal to 0. For even functions, a naught and an will be equal to 0s. Next, if the function f of x is an odd function, then which of the Fourier coefficient is 0? That is, an is equal to a naught and an will be equal to 0s, right? Okay, here the function is an odd function, then which of the Fourier coefficients is 0? A naught and an will be equal to 0s, right? Next, if the function f of x is an even, then which of the only Fourier coefficient is present? That is equal to n. If it is even function, then the function both a naught and an are present. A naught and an are present here, and bn will be equal to 0. Right? Next. Define the even function. A function f of x is said to be even if f of minus x is equal to f of x. F of minus x is equal to f of x. Next, when a function is said to be odd function, a function f of x is said to be odd function, if f of minus x is equal to minus f of x, So find the constant a naught of Fourier series for the function f of x is equal to x cos x in the interval minus pi to pi. Since f of x is equal to x cos x, what is f of minus x? F of minus x is equal to minus x into minus cos x, cos minus x, which is equal to f of x. So minus f of x, minus f of x. Therefore, the function is odd function. Hence, a naught will be equal to 0. He asked only about the a naught. So you can say that it is a naught is equal to 0. And here if you rectify that here a naught and an both should be equal to 0. The function is odd function. If it is even function, bn will be equal to 0. Right? Okay. If it is an even function, bn will be equal to 0. Next, what is a Fourier sine series of k in the interval 0 to pi? What is the Fourier sine series of k in the interval 0 to pi? F of x is equal to summation. N is an odd. We have to take only odd. It will be equal to 4k by n pi sine nx. 4k by n pi sine nx. And 4k by pi, if you take it outside, summation 1 by 2n minus 1 sine 2n minus 1 into x is a value for the Fourier sine series for the function k. Obtain the sine series for unity. It can be given by 4k by pi summation n raises from 1 to infinity 1 by 2n minus 1 sine 2n minus 1 into x, sine 2n minus 1 into x. Okay. By using the formulas for Fourier coefficients, we can able to find out the Fourier sine series for simple questions, simple function, that is k or unity, like that. Next, if f of x is defined in the interval x from minus 3 to plus 3, which of the what is the value of the Fourier coefficients? The values of the Fourier coefficients are given by, because f of x is not known, so I could able to give only the formulas for a naught, an and bn. So a naught is equal to 1 by 3 integral minus 3 to 3 f of x dx. And an is equal to 1 by 3 integral minus 3 to 3 f of x cos n pi x by 3 dx. And bn is equal to 1 by 3 integral minus 3 to 3 f of x sine n pi x by 3 dx. So what are the Fourier coefficients? The terms which consists of Fourier series along with their sine and cosine values are called as the Fourier coefficients. So what are the Fourier coefficients? A naught, an, bn are called as the Fourier coefficients, and these are the nothing but the terms which contains Fourier series along with their sine and cosine values. Sine and cosine values. Next, what is an importance of the Fourier series? The Fourier series is always is a way of representing any periodic waveform as a sum of sine and cosine waves plus a constant. The Fourier series is always used to represent any periodic function as a periodic waveform as a sum of the sine and cosine wave plus a constant. What are the Fourier coefficients? The term which consists of Fourier series, along with their sine and cosine values, the term which contains the Fourier series along with their sine and cosine value is called Fourier coefficients. And the Fourier coefficients are present in both exponential and trigonometrical Fourier series. Okay, Fourier coefficients are present in both exponential and trigonometrical Fourier series. Next, do exponential Fourier series also have Fourier coefficients to be evaluated? Yes, they are. They do have the Fourier coefficients to be evaluated. Next, Fourier series uses which domain representation of the signals? Frequency domain representation. Fourier series uses frequency domain representation for signals. Next, how does a Fourier series makes it easier to represent a periodic signals? Harmonically related. Next, Fourier series representation can be used in case of non-periodic signals too. True or false? It is false. The Fourier series cannot be represented for non-periodic signals because the very first condition that the function to apply for applying Fourier series is that it should be periodic in nature. What are the conditions called which are required for the signals to fulfill the representation of the Fourier series? Dirichlet conditions. We already discussed that the function should be continuous, that is, it should be piecewise continuous, and some of the conditions that a function should hold periodic function for applying the Fourier series. So these are called as a Fourier, that is Dirichlet conditions. What is a periodic function? Since the function's values remains the same value after the period, that is the functional value, the function gives same value again and again after regular intervals of time, is called as a periodic functions. Find a naught of the function f of x is equal to under root of 1 minus cos x by 2. Under root of 1 minus cos x by 2, that is nothing but 4 by pi. Okay, 4 by pi. State the convergence condition for Fourier series. The Fourier series of f of x converges to f of x at all the points where f of x is continuous. F of x is continuous. For every continuous function, it is always converges. At a point of discontinuity x naught, the series converge to the average of the left hand limit and the right hand limit at the point of the discontinuity. Suppose at 0 here the discontinuity is, then it converges at 0 minus plus 0 plus divided by 2. That is the meaning of the average of the left hand limit and the right hand limit. 0 minus represents the left hand limit of the function at 0, and 0 plus will represent the right hand limit of the function at 0. So therefore you can say that at the point of discontinuity, the average of these two has to be taken to get the point of discontinuity. The series convergency of the series at discontinuous point, and therefore f of x is equal to half into limit of x tends to 0 f of x plus h and limit of h tends to 0 f of x minus h. This is plus value. Next, find Bn if the function f of x is equal to x square. If f of x is equal to x square, that is an even function. For even functions, Bn will be equal to 0. Bn will be equal to 0. So therefore you can say that the Bn value, the Fourier coefficient Bn is equal to 0. Next, find An if the function f of x is equal to x minus x cube. If for the function x minus x cube, the An value will be equal to 0 because x minus x cube is an odd function here. It is an odd function. Okay, since this is odd function, this is an even function. Next, what is the Fourier series expansion of the function f of x of the interval c to c plus 2 pi? It is nothing but this is a very general equation formula for the Fourier series, that is a naught by 2 plus summation n rises from 1 to infinity cos nx a n into cos nx plus summation n rises from 1 to infinity bn into sin nx. Next, if the function f of x is even, which of the Fourier coefficients is 0? Bn will be equal to 0. If the function f of x is even, the last Fourier coefficient Bn will be equal to 0. If the function f of x is odd, then which of the Fourier coefficients is 0? That is always, if it is odd, then a0 and an will be equal to 0. a0 and an will be equal to 0. And if it is even, then Bn will be equal to 0. So this is how the definitions and terminology of the Fourier series can be explained. And for Fourier series, again recapitulating once again the summary of the definitions and terminology. In this session, we have learned the definitions and terminology of the Fourier series. Fourier series is a tool to expand a given function in that interval. It gives the expansion of the function in the sine and the cosine series. And based on the interval, the Fourier coefficients a0, an, and bn will have. For few functions, we don't have bn. For few functions, a0 and an will be vanished. Okay. So the type of the functions to which these three are: even functions, odd functions, half range sine series, half range cosine series. And one more thing, the Fourier we can't apply the Fourier series for all functions. The functions which are periodic in nature, and obeys the Dirichlet conditions, for that type of functions itself we can apply the Fourier series. And Fourier series is very helpful for engineering mathematics, because it gives us graphical structure of the function at that interval, and you can have the clear study of how the waveforms are going in that interval. So we have also taken examples of the coefficients. I mean, for how to calculate the coefficients of odd functions, and how to calculate the coefficients of even function. And also we also learned the convergency, and what is a discontinuity, of where it is converges, and when a function is said to be odd, when a function is said to be even. These are all the minimum knowledge that a student should hold, before starting the unit, applying the Fourier series to any functions. Thank you. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.